Hello everyone, welcome to the second video on the Laplace transform by using properties. So three properties that I'm going to show you here. Just a minute. The first thing, you should already know, you should know the Laplace transform of the standard results. Now, suppose if we know this Laplace, if the Laplace of f of t, if we know the Laplace of the function f of t is this capital Fs, then first property that I'm going to write it here is known as a first shifting property. So for first shifting property, we have the Laplace of e raised to at into f of t as f of s minus a. Not only this, by chance, suppose you come across Laplace of e raised to minus at into f of t, then you can write it as f of s plus a. So this is a first shifting property, So where it benefits, you can easily observe here. Whenever exponential term appears along with some other function f of t is there. So just take a Laplace of that remaining f of t and then shift s to s minus a or s plus a, depending on whether we want to multiply by e raised to at or e raised to minus at. So that about first shifting property. Then we have a second property known as Laplace of derivative. Remember, the first property is very important. The first property is very important exam purpose there. Uh, Second property is not so important. Not a single question is coming in last 3-4 years, or generally it is not so required. But yes, it required in the application when we solve the differential equation by a Laplace transform. So Laplace transform of derivative now. Suppose Laplace of f of t is fs, same thing. Then we have the Laplace of f dash of t. Laplace of f dash of t means ddt of f of t. So Laplace of derivative of that f of t is s into fs. This capital Fs is there, capital uppercase F is there, minus f of 0. Now this is lowercase f. So that is the property. Laplace of f dash of t is sfs minus f of 0. You have to remember actually three formulas at the time of application also. So better you should remember up to third order derivative. Laplace of f dash of t is sfs minus f of 0. Laplace of f double dash of t is s square fs minus sf of 0 minus f dash of 0. So this is for second order derivative. And the last third, Laplace of f triple dash of t is s cube fs minus s square f of 0 minus s f dash 0 minus f double dash 0. So this is a little lengthy, but yes, it rarely required in third order. Actually, in examples, uh, only the first two formulas are enough, but at the time of application to the differential equation, yes, all these three formulas we require. We'll come to that formulas at the time of application also. And the last property, third property that I want to show you here is Laplace of integral. So Laplace of integral of f of t dt, Laplace of integral f of t dt. Remember, the limits of integral should be 0 to t only. Laplace of integral 0 to t f of t dt. Now this, whenever we have definite limits, definite integral with the limit 0 to t, this f of t dt inside the integral can be any variable. Same variable t can be there, or t can be replaced by any other variable, because this variable is like a dummy variable. You can say integral 0 to t f of x dx also. So both are same. Then Laplace of integral is just division by s. So you have to remember like this: f of s upon s, f of s upon s. So this is so simple. Suppose we want the Laplace of double integral and both have the limit 0 to t f of t dt, then we have fs upon s square. So Laplace of integral is just a division by s, where in the property 2 you observe the Laplace of derivative we are multiplying by s. So when we take a Laplace of derivative we have multiplication by s, but for the Laplace of integral we have division by s. So the first property is obviously already I told is very important. Third is then it is the most important is 1, then important is a 3, and second is the least important, that for the numericals mainly, but at the time of application second property required. So you should remember these formulas. If you are able to remember these formulas, then only you can solve the examples. So let me see a few examples from handout only. So here is a first example where we want Laplace of e raised to minus at into sine hyperbolic bt. So first step, you should observe which property we can apply. So obviously, if you carefully observe, exponential term is there. Exponential term is there. Whenever there is exponential function, is a first shifting property. So we can find out the Laplace of the remaining part, this part first, and then we shift s to s plus a. That is one way. Okay. So in a solution, there are multiple ways to solve this example. The first way, yes, I will say like this. We want actually the Laplace of e raised to minus at into sine hyperbolic bt. Sine hyperbolic bt. So what I'm going to do it, I will ignore exponential function and I will try to get the Laplace of remaining. What is the Laplace of sine hyperbolic bt? So Laplace of sine hyperbolic bt is b upon s square minus b square. And because of that e raised to minus at, we have to shift s to s plus a, where we shift s to s plus a. This is by a first shifting property. So we got the answer b upon s plus a bracket square minus b square. So this is the way you can do it. This is one of the way. Generally, I show both the way in the first example, and later on I will do it by only one way. Or the other way of doing this example is first find out the Laplace of sine hyperbolic bt. You can say Laplace of sine hyperbolic bt is b upon s square minus b square, as it is hyperbolic denominator of the minus sign. Then you can say this is f of s. So by first shifting property, therefore by first shifting property, Laplace of e raised to minus at sine hyperbolic bt is f of s plus a. This is by first shifting. So we shifted s to s plus a, and we have to write the same answer then, b upon s plus a bracket square minus b square. So you can do it any one of the way. Either write this first part in the exam or this second part in the exam. So any one of the way you can show that in the exam there. So that about the example 10 from the handout. Next question. We have the Laplace of this one now. We want the Laplace of e raised to 2t into this bracket. So straightforward, that exponential term into some f of t is there. So we have to use that first shifting property. So in a solution, yes, you can approach in any of the way. So I will say first I will take the Laplace of this bracket and then I will use the shifting. So Laplace of 3t raised to 5 minus cos 4t is equal to 3 as it is, linearity property. Laplace of t raised to n is n factorial upon s raised to n plus 1. So it is a 5 factorial upon s raised to 6 minus Laplace of cos at is a s upon s square plus a square, that is here is a 16. So this is just Laplace of whatever f of t. So say this is fs. So we got the Laplace of the bracket. Therefore, by first shifting property, Laplace of e raised to 2t into 3 times t raised to 5 minus cos 4t is equal to, so it is by first shifting property, as it is e raised to 8 is there, so it is f of s minus a. Here is f of s minus 2. So final answer will be 3 into 5 factorial divided by s minus 2 raised to 6 minus, see every s we have to replace. So here this is a cos 80 is there, so it is s minus 2, we replace s by s minus 2 upon s minus 2 bracket square plus 16. That will be our final answer. No need to simplify, no need to simplify, keep this as answer. This one is the answer only. Okay, so that is the end of the question. These examples are very short, hardly 3-4 steps you get the answer. Okay, so that's the example 11. Next one. Carefully observe. Now multiple things we require. First of all, there is multiplication of trigonometry, which indicates we should use a trigonometric identity, and then at the end this term indicates a shifting. So let me find out the Laplace of sine 5t into sine 3t first. So here we require the formula sine A sine B. Sine A sine B is, yes, it is a 1 by 2 times 1 by 2 times cos of A minus B minus of cos A plus B. So when we start with this Laplace of sine 5t into sine 3t by the trigonometric identity, it comes as 1 by 2 times, this is cos of A minus B first, means cos of A minus B is cos 2t because it is 5t minus 3t, minus cos of A plus B, that is cos of 8t, cos of 8t. But because of the linearity property, this 1 by 2 comes outside, and Laplace of cos 2t becomes, Laplace of cos 2t becomes s upon s square plus 4, while the Laplace of cos at becomes s upon s square plus 64. Say this is our fs. This is fs. If this is fs, last part is left. Therefore, we want the Laplace of actually e raised to minus 3t into that sine 5t into sine 3t. So by first shifting, it says it is f of s plus 3, not minus, plus, because e raised to minus is there. If minus is there, here is plus, reverse sign is there. So this 1 by 2 as it is, now just replace every s by s plus 3 and we have the final answer. So it is s plus 3 divided by s plus 3 bracket square plus 4 minus s plus 3 divided by s plus 3 bracket square plus 64, and that is a final answer. Remember, here the answer is shown in simplified form, but no need to simplify. You can keep this as answer. This is the final answer there. No need of simplification. Okay, just that is our final answer there. Okay. So that about example 12. Nowhere there is no need of a simplification of the answers. You can keep the answers in the Laplace like this only. Okay, these answers are also accepted there. Next question. Similar to the previous, cos square is there and e raised to minus t is there. Cos square indicates trigonometric identity first. So first we'll find out Laplace of cos square of t. By trigonometric identity, cos square theta is 1 plus cos 2t divided by 2. So 1 by 2 is a constant outside, but the Laplace of 1 is 1 upon s, and the Laplace of cos 2t is s upon s square plus 4. So this is our fs. This one is the fs. Therefore, the last step, by first shifting Laplace of e raised to minus t cos square t is f of s plus 1, and the final answer should be 1 by 2 1 upon s plus 1 plus s plus 1 divided by s plus 1 bracket square plus 4. Keep that as answer. No need of any simplification. So this is the answer. No need to simplify like this. You can keep this as answer here. Okay. Okay, so the next one then, we want the Laplace of exactly parallel to that. So first Laplace of sine square theta, Laplace of sine square 3t is a Laplace of 1 minus cos 2t. Now here 2 double is it become cos 6t upon 2. So 1 by 2 is a constant as it is. Laplace of 1 is 1 upon s, and the Laplace of cos 60 is s upon s square plus 36. That about the answer. S upon, and lastly we want shifting. So Laplace of e raised to minus t sine square 3t is f of s plus 1, provided the previous function is our fs. By first shifting, we got the answer as 1 by 2, 1 upon s plus 1 minus s plus 1 divided by s plus 1 bracket square plus 36. Okay, so that is the final answer. No need of simplification as usual. Okay, next one. Here is a little different now. There is no exponential term directly involved, but we have cos hyperbolic into sin 80. Remember, there is no trigonometric identity which converts this multiplication to the addition. So we require Euler's definition of hyperbolic function. So here we start like this. We want Laplace of cos hyperbolic 80 can be written as, if you see the Euler's definition, it is e raised to 80 plus e raised to minus 80 upon 2. So this is the important step that you should know. And sin 80 will be as it is. Sin 80 will be as it is. So this 1 by 2 is a constant outside, and we left with Laplace of e raised to 80 into sin 80 plus e raised to minus 80 into sin 80. So just term by term multiplication. So this 1 by 2 will be as it is. Now here it is straightforward. This is sine only. Here in this example, in the first term, e raised to 80 into sin 80 is there. So this is straightforward of first shifting, where what we have to do it, we have to write a Laplace of sin 80 as a upon s square plus a square, but we are going to shift s to here is e raised to plus 80, so s to s by s minus a. We replace shift s to s minus a, plus for the second term same Laplace a upon s square plus a square, but we are shifting s to s plus a. So that about for shifting, and we get answer here as a upon s minus a bracket square plus a square plus a upon s plus a bracket square plus a square, and that will be our final answer. No need of simplification. You can keep as it is. Okay, you can keep as it is. No need to go do this type of the simplifications there. So you can keep the answers like this. Okay, the next one then. Exactly similar to the previous question. We want sine hyperbolic into cos square t. Yes, sine hyperbolic t, we can use it as a Euler's definition, but first we want Laplace of cos square t. Okay, so we'll do both the thing simultaneously, or let me find out Laplace of cos square t first. Okay, Laplace of cos square t, which is a Laplace of 1 plus cos 2t upon 2. So we get this as a 1 by 2, 1 by s plus s upon s square plus 4. This one is our fs. Therefore, Laplace of sine hyperbolic 3t into cos square t will become Laplace of this is e raised to 3t minus e raised to minus 3t upon 2 into cos square t. And here this 1 by 2 is a constant. 1 by 2 is a constant outside. And we left with the Laplace of e raised to 3t into cos square t minus e raised to minus 3t into cos square t. But already we taken the Laplace of cos square t, which is a f of s. So if this is fs, this should be f of s minus 3, and the second term should be f of s plus 3 by a first shifting property, Laplace of this. So a last step left here, 1 by 2 f of s minus 3 will be, already there is 1 by 2, so that 1 by 2 into 1 by 2 is 1 by 4, which is outside throughout. So in the first term we replace every s by s minus 3, so 1 upon s minus 3 minus s minus 3 divided by s minus 3 bracket square plus 4. So this is actually f of s minus 3 only we written, minus, now we are writing f of s plus 3, so this comes as 1 upon s plus 3, and that minus this minus, okay, uh, the previous mistake, I made a mistake here, this is plus only because here middle sign is plus, so minus, and this I also the minus s plus 3 divided by s plus 3 bracket square plus 4. So don't confuse with the lengthy answers. You keep as it is, no need of any simplification. This is the end of the question because we converted the function of t into the function of s. So final step, that is our answer. No need of simplification. Yes, these answers can be obtained by simplifying, squaring the brackets, simplifying, collecting the similar terms together, but no need, you can keep these as answers there. Okay, so that about the 16th example. There's few more examples which already asked in the old question paper. Out of that, we'll see the first and the third. They are simple. Second is also easy, you can do it your own. So here we want Laplace of t square e raised to 2t. So first we'll take Laplace of t square. Laplace of t square is 1 upon, sorry, it is a gamma 3 upon s raised to 3. Gamma 3 is a 2 factorial. Gamma 3 is a 2 factorial upon s cube. So Laplace of e raised to 2t into t square will be, suppose this previous is our fs, then by first shifting it is f of s minus 2. The answer will be 2 factorial. 2 factorial is 2 itself, and this is a s minus 2 bracket raised to 3. And that is the end of a question, end of the question of the first one. Now a third one we want Laplace of that bracket cube. So this is only the little different. So we want the Laplace of 1 plus t e raised to minus t, okay, and this bracket cube. So cube of the bracket is a little different thing, otherwise a first shifting property we require there. So is equal to Laplace of, now this is a plus b bracket cube, so a cube plus 3a square b plus 3ab square plus b cube. So So this is the term by term expanded. So this is a cube plus 3a square. A square means 1 square is 1. B is t raised to minus t plus 3a b square. B square means t square, and e raised to minus t square, e raised to minus t bracket square is e raised to minus 2t only. Similarly, it is a plus b cube there. And now here, term by term, the Laplace and the shifting. So Laplace of 1 is just 1 by s, 3 as it is. Here we take a Laplace of t and then we use a shifting. Laplace of t is, yes, it is a gamma n plus 1, that is a gamma 2, is it? T raised to 1 is there. So gamma n plus 1, that is a gamma 2. Gamma 2 is 1 factorial, is it? Uh, Gamma 2 divided by s raised to 2, where we shift s to s plus 1, where we shift s to s plus 1, plus 3. Laplace of t square is a gamma 3 divided by s cube, where we shift s to s plus 2. And the last one, Laplace of t cube, Laplace of t cube is gamma 4 upon s raised to 4, where we shift s to s plus 3. And the last step, therefore the answer is, okay, I will write the answer directly. 1 by s as it is, plus gamma 2 is 1 factorial is 1 itself, so 3 upon s, s plus 1 bracket square. Next, gamma 3, this gamma 3 is 2 factorial, so that is 2. 3 into 2 is a 6 upon s plus 2 bracket cube. And the last term, gamma 4, is a 3 factorial. 3 factorial is 6 again, and s plus 3 raised to 4. So this is the final answer. The final answer of that example 3 there. Sometimes these equations look very difficult, but they're not so difficult. Just you have to think on the problem. Think first, break the question into the parts, find out f of t, and then try to keep exponential functions separate at the end for a shifting there. Okay. So that about all the examples of the first shifting. Now we are coming to the second property, which is Laplace of derivative property, Laplace of derivative function. Already I told it is the least important property. These type of questions generally never come in the exam. The question is actually find the Laplace of cos 3t by using derivative. So you have to assume that as f of t first. So let f of t, as we have to use derivative properties, so we use given function as f of t, which is cos 3t. My mistake. This cos of 3t. So f dash t will become, find out the derivative. Derivative of cos 3t is a minus sine 3t into 3. So minus 3 sine 3t. So you should know the derivatives importantly again. So this is minus 3 sine 3t. Now we have this property. We use the derivative property because the question is itself use the derivative property as Laplace of f dash t. What is the property? Laplace of f dash of t is s into capital Fs minus small f of 0. Now two things we require, capital Fs and small f of 0. First of all, first of all, you will observe. So here we get a Laplace of f dash of t. Okay, f dash of t means Laplace of minus 3 sine 3t, but we want Laplace of cos 3t there. Okay. So we can do the reverse also. Let me assume f of t as just 1 minute only. This is Laplace of f dash of t means Laplace of minus 3 sine 3t will get, and from that, yes, we want fs. What is fs? Fs is the Laplace of f of t. Correct. My mistake. So this gives us, just replace on left hand side, Laplace of minus 3 sine 3t, that is s fs. Now just check f of 0. What is f of, this is small f, this is lowercase function f. So f of 0 means cos 0. Cos 0 is 1, is it? So minus 1. Minus 1. See, what is capital Fs? Capital Fs is always a Laplace of f of t. And that we want. So we want Laplace of cos 3t, means we are going to find out the value of this capital Fs by solving this expression. So on the left hand side, minus 3 is a constant as it is. And we know the Laplace of sine 3t. Sine 3t is 3 upon s square plus 9, is it? This minus 1 I will take on this side, plus 1 is equal to sfs. Simplify this side. So this is a minus 9 cross multiplying plus s square plus 9 divided by s square plus 9 is equal to sfs. So you'll observe first of all this minus 9 plus 9 gets cancelled. Then then after that cancellation, you'll observe this one s gets cancelled here, and we left with the required one, that is capital Fs, which is the Laplace of f of t as s upon s square plus 9. And we know this Laplace of cos 3t by standard result only is s upon s square plus 9. But this type of the questions are never coming in the exam, so don't worry too much. Yes, but you should know how we can get the Laplace of the standard function also by a derivative property. So this is the first example. The first example for getting the Laplace of cos 3t by a derivative property. One more example, find the Laplace of t square by derivative property again. So as f of t is t square now, so we have to use the derivative property. So let me start with that. Let f of t is t square only. So we have to find out Laplace of ft, means we have to find out capital Fs. But in this case, we get two derivatives here. So f dash of t as a 2t, and we know here one more derivative that we can take for this algebraic, that is a 2 only. F double dash of t is a 2. F triple dash is a 0. Now let me use a derivative property, but we use the derivative for f double dash. So that's better. So as Laplace of f double dash of t is s square fs minus s f of 0 minus f dash of 0. So this is the property that we have. So this goes Laplace. What is f double dash here? F double dash is 2 only. So Laplace of 2 on the left hand side. F double dash of t is 2 we got. On the RHS we have s square into capital Fs that we have to find out, which is Laplace of f of t. But you will observe f of 0 now. If you replace in this function, small f of 0 is a 0. What is f dash 0? F dash 0 is also 0. If you replace t by 0 in f of t and f dash of t, we get a 0. So it is a minus 0, minus 0. So it doesn't affect. What is Laplace of 2? Laplace of constant, the 2 is constant as it is, and we left with Laplace of 1 is 1 by s. So 2 into 1 by s. So that is LHS, and on the RHS we have s square fs only. So the we got a required answer, which is capital Fs is 2 upon s cube, and that is the required answer. You can easily cross check by a standard result property. We have the property Laplace of t raised to n. Laplace of t raised to n is gamma n plus 1, which is a gamma 3 upon s cube. Gamma 3 is a 2 factorial. 2 factorial is 2 itself, which is, and that's the same answer. We definitely we have the same answer, only there is always a unique answer, and you can approach in the different way. That's the second example. One more example I want to take it here, but that is not in the handout, which is a Laplace of find the Laplace of d dt of sine t upon t. Sine t upon t. Actually, this question is not in the handout, but suppose this question comes in the exam already. Okay. First, you will assume this because d dt of ft we want, so that is f dash of t. So let f of t is sine t upon t, and we want Laplace of f dash t only. So as Laplace of f dash of t, Laplace of f dash of t is sfs minus f of 0 minus f of 0. So here we want Laplace of sine t upon t. Okay, actually you will learn this property, you will learn in this property, division by t property, and that time you will come to know the Laplace of sine t upon t. I will use it directly here, but later on, uh, only one thing I want to tell you here. What is f of 0? F of 0 is sine 0 upon 0, which is indeterminate form. So actually we want the limiting value of sine 0 upon 0, that is 1. So this is S, and Laplace of sine t upon t, you will come to know the later on in the next type there, which is a cot inverse S. Directly you can use it, or you can prove it. S cot inverse S minus 1. That will be the answer. The small f of 0 is 1. That only I want to show you here. But yes, I will. You'll come to know in division by t property that Laplace of sine t upon t is cot inverse S. This is one of the standard example, number of times coming in the exam there. Okay. Okay, so the last property is Laplace of integral, and one of the simple property, one of the simplest property that you have, because what is the Laplace of integral? When the limits are 0 to t, the Laplace of integral is just division by s. So we have to break the function now. First we have to find the Laplace of f of t, and at the end Laplace of integral is a division by property. So start with the Laplace of cos t first. Laplace of cos t is s upon s square plus 1, s upon s square plus 1. But by first shifting property, Laplace of e raised to minus t cos t, it become f of s plus 1. So we have to shift. If you say this is fs, this is f of s plus 1. So shift every s to s plus 1. So this is s plus 1 upon s plus 1 bracket square plus 1. So this is by first shifting property. Okay. And lastly, therefore, if this is now new fs, suppose you say this is a fs and this is f of s plus 1, you can denote it by some gs also. And you say Laplace of integral 0 to t e raised to minus t cos t dt. Laplace of integral is just division by t. So whatever gs we got, we divide that gs by s. So gs is actually s plus 1 divided by s plus 1 bracket square plus 1 divided by s. So I will just use a square bracket, and that divided by s I will write it here. So this is the end of a question. That is the answer. That is the answer. So see how simple property is there. When we want to take the Laplace of integral 0 to t f of t dt, it just become fs upon s. Divide it by s there. Exactly similar way you can get it here. You can take Laplace of sine t first, and Laplace of e raised to t then, and lastly the Laplace of integral. So Laplace of sine t is 1 upon s square plus 1 first, then Laplace of e raised to t sine t is f of s minus 1. If this is your fs, this is f of s minus 1, and the answer is 1 upon s minus 1 bracket square plus 1, and suppose this is the gs. Then last step, Laplace of integral 0 to t e raised to t sine t dt is gs upon s, and the answer is 1 upon s into that s minus 1 bracket square plus 1. So this is the end of the question. Okay, so we are applying the properties one by one. We are splitting the function. First we take on sine t, Laplace of sine t, then shifting property, and then integral. Okay, so integral is outer one. So we have to apply the Laplace of integral property at the end only. Now already I told this inner integral is like a dummy variable. So we want the Laplace of integral 0 to t x square e raised to x dx. It is nothing but integral 0 to t square e raised to t dt. Both are same. So we take a Laplace of x square first, or Laplace of t square first. So Laplace of t square is gamma 3 upon, or 2 factorial, that is 2 upon s cube, 2 upon s cube, that is our fs. Then Laplace of e raised to t square is say f of s minus 1. So it is a 2 upon s minus 1 bracket cube, and lastly say this is a gs, and last property that we should apply, which is a Laplace of integral 0 to t e raised to t square dt. Now I am not used x variable, that's okay, you can write in t or x, it is in inner variable is like a dummy variable because limits are there. You can write anything inside the, you can write e raised to z, z square dz also, okay, anything. So that is gs upon s, and the final answer will be 2 upon s into s minus 1 bracket cube. Okay, so that about the example 3. Last question, the last question which is already asked in the IMU exam. It looks very complicated. You may think we have to do triple integral. Nothing like that. Triple integral means you have to divide s 3 times only. That is so simple. First take a Laplace of sine t, then multiplication by t property, and then the triple integral. So multiplication by t property you'll learn first. Okay, you'll learn that multiplication by t property, and then the Laplace, this triple integral property. So better uh, at the end just it is divided by s cube. So when you learn the multiplication by t property, that time only you can do this question. Okay, so I'll skip it right now. Thank you so much. That's for today. Thank you.